Welcome, everyone, to today's presentation on FinAcumen. Today, we are discussing a major paradigm shift, prioritizing experiential memory over parametric scaling. We will introduce a dual-engine framework designed specifically for high-stakes financial multimodal reasoning, which utilizes a self-evolving experience system alongside deterministic tools. Let's begin by examining what we call the high-stakes illusion. Financial analysis fundamentally requires processing heterogeneous evidence, which means models must successfully handle joint visual interpretation, numerical computation, and temporal grounding. General-purpose models suffer from the brittleness of static weights because they lack grounded strategies, while finance-specialized models lack out-of-distribution robustness. Furthermore, finance is a true zero-tolerance environment. Analysts require exact match requirements and 0.2% numerical tolerances, and there are severe penalties for hallucinated evidence. In this field, being merely close is not enough. To solve this, we must move away from standard frameworks like the amnesic agent, or react. This traditional approach is largely stateless across episodes, meaning it repeatedly rediscovers the exact same reasoning strategies and failure patterns. Instead, FinAcumen acts as an evolving agent. Just as human experts rely on accumulated experience, our agent separates reusable strategies from failure-derived cautionary rules, storing them securely in a vault to pass across episodes. Here is the blueprint of FinAcumen: 2 engines and 1 frozen core. At the center is our frozen base model, the Quen 3VL8B Instruct. On the left is Engine 1, the financial memory, which provides probabilistic guidance by accumulating financially grounded reasoning experience from prior trajectories. On the right is Engine 2, the financial tools, which handles deterministic execution by offloading tasks like computation, data retrieval, and visual decoding to an exact, rule-based environment. We evaluated this framework across a strict dashboard of complexity consisting of 4 benchmarks. First, BizBench tests SEC quantity grounding, challenging the model with dense distractors and a 1% exact match requirement. Second, FinMMR evaluates multimodal numerical reasoning against visual noise and multi-step arithmetic. Third, FinTMMBench tests temporal-aware multimodal RAG, focusing on time anchoring and retrieval failures. Finally, FinMME assesses broad-spectrum chart evaluation across diverse chart semantics. Let's take a closer look at Engine 2, our deterministic safety net. It utilizes 4 specialized tools. The numerical reasoning engine uses Python execution within a persistent namespace to solve arithmetic inconsistencies across multi-step chains. The grounded data retrieval tool prevents hallucinated metrics by checking facts against a curated panel of SEC tables and OHLC records. The visual structure decoder fixes ambiguous chart reading using an OCR-first transcription approach. Finally, the answer consolidation gate serves as a termination gate enforcing source traceability, formatting, and unit consistency. Why is that persistent namespace so important? This slide illustrates the cost of statelessness. Standard stateless code generation wipes memory between calculations, such as moving from revenue to growth rate to margin. This forces the model to reinitialize all quantities per call, risking catastrophic chaining errors. Because financial multi-step reasoning chains intermediate quantities by nature, FinAcumen uses a persistent namespace to preserve this dependency safely. Now, let's explore Engine 1, our strategy and caution distillation engine. Through multi-trajectory raw sampling, independent solution attempts are synthesized by a summary agent. The agent distills these findings into 2 categories: reusable strategies and cautionary guard rules. These generalized rules are then distilled and written into a read-only memory bank for future inference. To ensure we don't inject irrelevant information, we use selective retrieval via a tau gate. When an incoming query arrives, it passes through a cosine similarity filter set at a threshold of 0.65. If the match is below 0.65, we explicitly suppress noisy memory and gracefully default back to base React reasoning. If the match is above 0.65, the memory is deduplicated, ranked, and personalized to the query entities by an annotator agent before being injected. The agent evolution matrix clearly highlights our advantages. Standard React agents are amnesic, repeat past failures, and suffer from unfiltered, retrieval-heavy context injection. In contrast, FinAcumen maintains persistent cross-episode experience, explicitly warns against known traps with cautionary guard rules, and uses tau-gated, personalized context injection to block irrelevant noise. The empirical proof is in our benchmark dominance. FinAcumen consistently improves our frozen 8 billion parameter base model across the board. For example, on BizBench, accuracy jumped from 27.67 to 68.65. Most notably, on FinMMR-Easy, FinAcumen achieved 81.67, which actually beats GPT-4o's score of 78.00. It outperforms finance-specialized models and approaches the performance of leading 72 billion-plus proprietary models. How did we achieve that massive gain? This staircase of capability deconstructs our improvement. Starting from the base model's 59.17%, adding Engine 2's deterministic tools provided a huge 14.91% increase by resolving execution-level errors and calculation consistency. Adding Engine 1's memory provided a further 7.59% boost by supplying strategy-level routing and specific financial traps to avoid, bringing us to our total of 81.67%. Importantly, we found that infinite memory is unnecessary. This S-curve of saturation shows a rapid initial climb as we accumulated prevalent error patterns. However, we hit a knee at exactly 1,800 entries. The diminishing marginal returns beyond this point prove that a compact, highly distilled bank of 1,800 experiences successfully captures the vast majority of financial reasoning archetypes. In synthesis, the old paradigm of static parametric scaling requires massive 100 billion-plus parameter models, which results in high inference costs and persistent hallucinations. The new FinAcumen paradigm utilizes dynamic experiential routing. By offloading reasoning to a dynamic query-conditioned memory bank and executing via deterministic tools, we enable elite domain mastery with only a fraction of the parameter scale. Ultimately, the future of high-stakes AI is not just larger brains, but evolving experience and specialized tools. Thank you.